Well, I mostly do leather work. I also dabble in a few other hobbies, and blacksmithing is one of them. And I finally have put together enough of the tools, equipment, and gained the skills to do a project that I've been wanting to do for a long time, and that's make myself a really nice round knife for leatherworking. So I'm starting out with 18 pieces of steel here. There's actually three different types of steel, and one of them was kind of a bad idea. I've got 8670 in there, which is the bad idea, and then it's 1075 and 15N20, both of which are really good for what we're doing. And why 8670 is a bad idea is going to come up in a little while. But I'm pretty much just the standard, you'll see it in blacksmithing videos, bringing it up to, warming it up to red heat and fluxing it, and then going and bringing it up to a welding heat and taking it to, in this case, I've got a hydraulic press, and starting to press it all together to form all those little pieces of steel into one big piece of steel. First couple pressings of it, you kind of go a little gentle on it. Just squish it a little bit, just to make sure the weld's set. And once it's set pretty solid, one solid chunk of steel, then you bring it back up, and I'll work pretty much at welding heat each time, but I can start squishing it down and really drawing it out. Now I'm using a little block of steel in there as a stop, basically, to only be able to draw it down to a certain amount. So I'll make a nice even bar about 3/4 of an inch thick out of this once I get it all drawn down to where everything's hitting that block. And then I don't have to worry about things being wobbly and uneven and not matching up when I go to try and fold 18 layers into 36 layers. It's probably going to be one more heat of drawing it all out. It's getting just a little too cold. Now, I'm going to use I've heard them called hack tools, basically to split the bar into two pieces. And then back to the anvil to try and clean it up, get it bent around, fluxed and folded, all put back together, and then we're going to try and weld those pieces back into one solid mass. Back to the flux, which in this case is an anhydrous borax. It's in a coffee can because it was given to me by another smith, actually named Smith, years ago, when I was first starting on all this. And I really have never used a lot of it, so I still have a bunch of it left, so I've been using it ever since. But since he was somebody that did this professionally, I took his advice and I'm using the flux he gave me. Now here's where everything starts to go wrong. Because I folded it around and I didn't know which way I had everything turned and so on and so forth. I had that 8670 steel in there. And I managed to fold it around where I had 8670 trying to weld to 8670. And at the time I didn't know that that was going to be an issue. But as you can see, it's not sticking together. It keeps popping apart each time I go to squish it. And that's because 8670 has a little bit of chromium in it, along with some other stuff. Just enough that it's not stainless steel, so it doesn't have all the advantages of having chromium, but it's got just enough chromium to form those chromium carbides that make it really hard to weld together. So it doesn't want to weld to itself very well. So I tried 2 or 3 times to squish it all together, and it keeps just opening back up. And before I get it too thin to where I have to completely just toss it and start a new billet, I decided, okay, I'm going to take it apart, take it over to the grinder, and grind it all off smooth. Of course, I have to wait for it to cool and cut it down, so I didn't video all that. It was about a 20-30 minute process. But I eventually took it apart, cleaned it all up, and put a weld down the side, and then welded it together again like I was starting a new piece. And that's what I'm working on here, is I'm starting to do the weld to actually put that together. And it stuck, mostly. It still was problematic, it didn't want to stick very well, and I wound up with a few delaminations that I had to deal with. And at the time I didn't know if I had a piece of steel that I could actually use or not, or if this was going to be just an expensive piece of scrap metal. But I figured I'd give it a shot and see where it went. But it did weld together fairly well. Like I said, there's kind of a line running through it that you can tell where that weld is. But if you look at the color of it, it's a nice even heat. So it's a solid piece of steel. And that's my basic billet. It's 36 layers, like I said, 3 different steels. So I'm going to leave that to cool, and actually I'm going to leave it overnight, come back the next day and cut it up. And I'm going to cut a piece out of it about 2 inches square. And that's going to be what I'm actually going to work to make the round knife out of. And it goes back in the forge. Have everything ready, tongs, hammer, anvil, all ready to go, and I'm just going to be working on the edge of the anvil, trying to put little V dents in the side of this, so that I have a place that the press can get a hold of, so I can isolate off a piece that can be the tang of the knife. About halfway down the side of the square piece. Maybe not even that, maybe about a third of the way down the side of the square piece. On 2 sides that are adjacent to each other. I actually spent a lot of time thinking about how I was going to get a round knife shape out of a piece of steel. And how I would be able to isolate that tang out and pull it out and be able to pull the shape out. So, once we've got that, then I can go to the press and I can be able to catch it just on the edge of those dies. Kind of squish that tang out and it'll just draw out into a piece that nice little square lump about 3/4 of an inch cube that I can draw into a tang later. So now I basically have a little block with an ear sticking off of it. It's mostly still a square about 2 inches by 2 inches by 3/4 of an inch thick. So I want to round it out a little bit. I'm going to pound down that point. That sticks up away from the part that I've isolated for the tang. And I could have probably brought those corners down at this point too, to make it more the shape I wanted it to be. But I have plenty of extra steel, so my plan is that since I'm not a professional smith and I can't forge really close to shape, is that I'm just going to do the factor P for plenty and really draw out a whole big punch of steel into a large shape and then cut and grind it back to the shape that I want it to be, rather than try to use just enough steel and work to pull it out to the shape that it needs to be, because like I said, I'm just not that good at smithing yet. But with the combination dies that I have and this fullering die that I've made, I'm going to squish it all out into one big kind of tortilla shape looking piece. Tortilla chip shape. But it's going to be plenty of steel that I can work with. I'm also forging in a little bit of an integrated bolster into the blade. This is the obligatory blacksmithing slow motion shot to show the sparks flying. It's actually pieces of scale popping off. But as you can see, the blade's starting to take shape. I've got that 3/4 inch piece that I'm holding on to with the tongs. It's going to be the tang. Another advantage of doing this, since it's just a random pattern Damascus, using a lot of fullering and rounding hammer faced blows, I can really kind of mess up that pattern in the steel and get something a little bit more interesting. So if I forge this kind of thick and rough and then grind it to shape, it's going to be a more interesting look in the long run. Now, you can't plan what that look's going to be. You just kind of got to guess a little bit that it's going to come out in a neat pattern, because, again, I'm not that good of a smith. Somebody who's really good can be very careful with their forging and come up with the exact what they want, even out of a random pattern. Or they could make one of the fancy patterns and not distort it with their forgings because they know what they're doing. But I'm not quite there yet. So I'm drawing out that tang, a couple heats just to taper it. And round knives don't have a real long handle on them, or at least they don't need a very long handle on them, 2 or 3 inches long at most. I think I've had them up to about a 4-inch long handle on it, so a 2 and a 2.5 inch long tang should be plenty for what I'm going to do. Now, proper safety gear, which I didn't show the respirator because I'm already wearing it, and forgot that I was wearing it at the time. But you should always wear gloves, respirator, and ear protection and eye protection whenever you're doing anything with grinders, because they have a tendency for pieces to fly off in random directions and bounce off of things. So I'm not going to show the I don't remember how much time it was, half an hour, hour's worth of grinding that got me to this point. But you can see I've got that sort of integral bolster in the center of it, the drawn out tang, the blade has been thinned down, and we move on to heat treating it now that I've got it fairly smooth. You want as many of the big scratches out of it so you don't have points that are going to be problematic in the heat treat. And you don't want uneven thicknesses as much because that can cause warps. But we're just going to heat it 2 or 3 times up to the point that's non-magnetic and quench it in some oil. And you can see we got the gray spots on the blade that show that we've got a nice hard, that the steel has hardened. I did test it with a file. It skated a file just fine. But then we're going to go to finer and finer belts to clean it up. And finally some hand sanding after it's been in the oven for a while to temper it. It's got a little bit of a gold tone there that comes from that. Once it's all cleaned up and polished nicely, it's going to go into ferric chloride for an etch. Actually, it goes into ferric chloride 2 or 3 times for etches for various lengths of time. And then, once I get it all cleaned up, this is the finished blade from